Hello, everyone. My name is Juliana Battaglia with Parker Hannifin's Electronic Motion and Control Division.
And I'm Kirk Lola, Product Manager for Parker Hannifin's mobile display products.
Today, we're here to provide an overview of the development environment used on Parker's PhD line of mobile displays. These tools help users develop and debug applications faster by providing an easy-to-use graphical programming environment and no hardware in the loop simulation. After this video, please feel free to visit www.parker.com/phd and www.cranksoftware.com for more information. Now, to kick things off, Kirk will start by giving a demonstration of the tools.
Thanks, Juliana. Our customers have told us that making the application software development process quick and intuitive is very important to help reduce development time and cost. Two key features to this are development environments that allow the developer to see the screens during development exactly as they would show up on the screens on the target hardware, and the ability to simulate the application in the development environment for faster debugging. The PhD displays use the Crank storyboard development environment for application development, and Parker developed software for hardware-specific tasks such as configuring wake events, configuring I/O ports, as well as downloading to the hardware. I'll bring up the Crank environment here. The Crank Development Suite offers an easy-to-use graphical programming tool to create display screens and events. When developing screens, it is very important for developers to be able to see the screen designs and actions in the development environment that match the screens as they would appear on the actual display. Not only does this help reduce development time and cost, but it also allows the developers to create more screens that include better graphics and animations. The application that I've brought up is a simple screen with some basic animations, a video feed, and a scrolling list. You can see the screen layouts are exactly as they appear on the target hardware. In addition to the screen layouts, the development environment also includes support for Lua scripting where the application logic is done. This has really helped simplify reduced development time by not having the application developer switch between development environments to do both the screen layouts and the logic programming. As the application is being developed, the programmer can simulate the application in the Crank environment without any hardware in the loop. This saves debugging and development time by eliminating tedious back and forth by downloading to the hardware, checking the functionality, changing the software, and going back and downloading to the target hardware again. So this greatly reduces development time. So I'll start the simulation, and you can see that the screen on the simulation appears exactly as it does on the target hardware. And this provides the developer with instant feedback on the appearance and operation of the screens. You can see the functionality and the simulation is exactly as it is on the target hardware. However, in many cases, the developer needs to get feedback from people across the office or even across the world. In these cases, not everyone has access to the Crank environment or PhD hardware. This is especially true for large global companies that are looking to standardize the look and feel of their screens across many divisions and design locations. In these cases, it is possible to export the simulation to a Windows executable that can be run on a Windows PC without having the Crank environment or even PhD hardware available. To do this, we simply select the option to export the application. Once this is done, it will store that file on the PC, and then this can be emailed or sent to others for consultation, review, collaboration, or approval. This feature significantly helps reduce development time by allowing developers, collaborators, and approvers to consult very quickly on design formats and functionality without having to rebuild the application in another location or having PhD hardware in another location. So I'll bring up this export, the simulation we created, and run that. This runs on the Windows PC, separate from the Crank environment, and you can see the executable runs exactly as the simulation did. Functionality is there as well, so that can be tested. And this allows, like I said, this application to be sent around the world to anybody to run on their Windows PC for evaluation and feedback. In addition, Feedback from our customers has told us that many times other users, such as service technicians and production line personnel, or other users besides the application developer, would need to load applications on the target hardware. For this reason, PhD Packager from Parker is a standalone tool separate from the development environment. I'll go ahead and bring that tool up. So we'll bring up the Packager. This is an easy graphical tool to allow the different selections to be made. Okay, we'll start off, we'll select the target hardware, in this case, the 1 GB PhD-70. We'll select and move on to the next screen where we select the application to download. Okay, in this case, we'll select the application that we're working on. Select that. We can also select to install firmware updates if they're available. In this case, we don't need to install a firmware update. We'll move on to the next options where we can select the orientation, some hardware configurations, and a new splash screen as well if you want to customize the splash screen. Okay. The next screen allows us to go through and configure the wake modes. So the PhD support a low power sleep mode. And this screen lets us select which actions wake the PhD from its sleep mode. These can be an input, they can be a can, they can be a touch event. Any of these can be selected on this screen. Then the last is where we enable the CAN settings. This is also where we can select the CAN definition files. For example, a J1939 JSON file or a CAN OpenEDS file that are used to define the CAN messages. Then the last screen is where we actually connect to the PhD target hardware and download the application. So we'll connect, we'll select build, and you can see that we get progress as the application is being built. The developer can see this. Then in addition, it'll connect to the PhD, and we can see the status on the screen of the PhD, as well as on the PC itself while it's being downloaded from the Packager tool. This is very important for users to be able to see this update, because that way they know when the application's been updated, they don't accidentally remove power before it's done, and they can see that it has also started the update process and know that the update's begun. Okay. We'll get this complete, and then we'll see the PhD reboot. When the PhD reboots, it'll come back with the application we downloaded, and we can see the application that we've downloaded matches the application that we simulated and the application that we used in the development environment. So the application screens look the same as we simulated, look the same that we could send to people anywhere in the world, and is now on the target PhD.
We hope you found this video helpful and demonstrated how the software development tools for Parker's PhD line of mobile displays provides a seamless, easy-to-use graphical programming toolset that helps reduce development time and cost. In addition to helping reduce costs, these tools also offer developers an environment to create feature-rich, sophisticated screens for mobile applications. Again, if you'd like more information, please go to www.barker.com/phd and www.cranksoftware.com.